much once again. Now we move on to the next session. TRIAD in action, EO, PNT and cost integration for strategic advantage. This session will explore the synergies between the three critical technologies, highlighting their combined impact on situational awareness, operational efficiency, and decision-making for military and civil contexts. For the same, I call upon the Chair, Air Marshal Anil Chopra, former DG CAPS, Lieutenant General Pannu, former Deputy Chief of Directorate Staff, Lieutenant Colonel Shanmuga Velan, Elena Geosystems, Brigadier Anurag Asthana, Brig OPS Artillery Directorate Army Headquarters, Ms. Neelavathy, Project Director GSAT 7 or GSAT 7B Water Satellite Center, and Mr. Pramod Konugurthi, Senior VP Space and Data Engineering, XDLINX Lab. Over to you, Chair.
Third day post-lunch session, graveyard shift. That is what the Paracode boys used to call it. Difficult to remember the training, but I hope and we will make an endeavor that each one of you is kept alive and listening as we go through this panel. The subject that would be on TRIAD, three important areas: electro-optical, PNT, and communications. All three very, very important areas for both military applications and civilian applications. We are running behind time by about 5 minutes. So as a chair, I'm not going to take too much of time. All I want to tell you is that each element in its own self is very, very important for military and civil applications. But together, they need to coordinate. Who's going to do this coordination? How do we work together? Because all the elements need to work together at the same time for getting the operational experience. But this is nothing new. The army with the old times, the elephants, the horses, the foot soldiers, they all used to coordinate and get to their correct targets and defend themselves. Similarly, the airspace management in the country will be managed jointly by all of us. The Army, Navy, Air Force, all of them are flying. There are many other civilian, airborne assets, and the coordination is going on. And therefore, I don't see any major problem to be able to get to the big differences that in space there are different agencies who are currently holding different assets, and therefore a central coordination, whether it be a space force, as was discussed in the previous session, some kind of a joint activity will have to take place, a command and control will have to be exercised, the space agency, space command, somebody will have to make sure that our assets are safe, and if tomorrow somebody threatens us, we should be able to threaten their assets. With this background, we're going to start the session. We have the best brains in the town in the session with us today, and I'm going to start first with General Pannu, who's been Deputy Chief of Army Staff, but more than that, he had for the last 4 years been very actively associated with the space, especially SIA, and he's been, in fact, coordinating the committee, or rather, he was the coordinator for most of the last 4 big events that this organization has done. So we will start with the please.
Thank you, Marshal. Chopra, sir. He's been an ace fighter pilot, and also he headed the space and I would say aerospace academic way in the Indian Air Force. And now, of course, he's free to speak his mind, and not that he was not free earlier, but I think it's the right time that we put him here. We are today sitting at a spot where ISRO and the ecosystem that ISRO developed over a period of time was responding to certain space requirements which were non-military. I would not say civil. And why I say so is that when all those space assets were being built, military was not in their mind. But when we start looking at militarization or the military grade use of space, we realize that a future of space can be best seen by a pilot of the past. An aerial platform which goes and does the reconnaissance or sends pictures of what the pilot sees, or pilot who is actually carrying a weapon platform, sees a target, identifies the target, destroys the target, and does the post-strike damage assessment and comes back, has now looked at a huge amount of human cost involved in this because of the risk of having a manned aerial platform to warfare. All that had to be done in huge quantities, a number of aircraft flying over large swaths that they couldn't distribute. As a result, space came as not only the replacement but as the partner. And as a result, the pilot now could go to an area where the space indicated that they could go and do the job. And over a period of time, the space could only tell them about the Earth observation. Space could also aid them in communication, but space could not aid them in targeting. They had to do their own targeting. So today, when we are talking about militarization of space, we find that if you have to take decisions, the decisions will be based on meshed intelligence. It means the sensors that are looking and processing the information of the ISR, brought together for decision making, processes the whole thing which is meshed intelligence, and later on you have to use the same information for targeting, which is meshed operations. Now this entire loop has to be done through the space domain. So you realize that there are three attributes of the space, that is the ISR, the communication, and the PNT have to be brought on a common thread. And if ISRO or the space ecosystem has not, from the beginning, looked at the three attributes that I've spoken about, the PNT, communication, and the ISR to be brought on the common thread, then they have invested this separately. How do we start looking at bringing all these space assets which can either be hybrid? Now, the ISR itself can be hybrid, as was being spoken, that there is the electronic warfare. So you have to do ELIM, you have to do the EO, you have to do SAR. All these payloads got to be put together for edge computing, and they can be fed into through the geospatial arrangement into a mosaic of war information feed in, so that the war planning can take place on the mosaic. Once all that happens, now you have to target and decide deep precision strikes. The cost of striking a target is humongous, and you cannot, as the Chinese have gone in for space, aerospace separately and information warfare separately. Why they have done so is that if you think this is a target, they will make sure that it doesn't look like a target, or you will invest in a wrong target and you will hugely invest in targeting or fighting the war the way they have designed it for you, and they will still come out of it. So therefore, they are going to use space and their aerospace to make sure that you are fighting their battle, which you think is your weapon. So I think there is an information warfare intent fell into it. So therefore, in the edge computing, in processed or meshed intelligence, we have to make sure that what is there, you understand it and you have to strike it as you desire, so that you are not investing wrongly. So today we have on the panel Brigadier Asthana, who's from the Directorate of Capital. And then, of course, I will come to the others, the PNT and the TSAT, we will talk about it. But straight away, I will go into discussion. Brigadier Asthana will tell us, as I spoke about the Air Force, which of course, Marshal Chopra will want to talk about. How does artillery look at standoff engagements, where they do not have the physical observation of the target, as the ranges keep increasing, as the guns get more precise and optimized? How the missile warfare and the guns put together, so the guns and missiles coming in for deeper and more precision strikes, how does he feel that this transformation should take place? And then, of course, I will talk about this. Brigadier Asthana.
Thank you, gentlemen, Rafi and the presenter. Where Pannu left off, one thing to mention before I go into targeting is surveillance. We have to know, like he said, that when we reach that stage of war, so when we wait to engage a wrong target, that's where the surveillance comes in, which is the first stage of understanding the targets that we reach. Air Force can manifest at a given time, at a particular point, when directed to use for obedience. However, the terms of war probably will start building over time, and that is when the enemy would start making his chess moves, which have to be kept under surveillance, in order to understand how his final outcome is going to be. So, first aspect about this TRIAD that we are discussing is the surveillance. And space assets provide us that persistence by virtue of being up there, being at the ground every time, taking pictures of the intelligent areas at various times of the day, times of the night, with different payloads, so that as and when information is required to be clean, can be. That is the first aspect. The second aspect is using this information accentuated by a suitable georeferencing or geoinformation software to understand the coordinates that are going to be targeted. Today, the weapons are all very precise. They take coordinates and they guide themselves to those coordinates that are fed into these missile coordinates. But in order to ensure that they go to the right place, we should be able to tell them where to go. So that is the second use of the surveillance, is reading the correct coordinates of the target and then guiding them. Subsequently, we come to the communication between the weapon, which is going to be launched, to that particular target, as alluded. It's beyond visual range. We don't see the target, but we see the engagement. That's what we have been seeing in the various conflicts that are spawning in front of our eyes. So the communication has to be of such a nature that it doesn't deviate by any countermeasures and is present as per the requirement in correct format, as per the correct signals to take the weapon to that particular target. The next connected part is the positioning of our own forces. When I have to launch a weapon, my own launcher has to know where it is located, so that when that launcher is put into action, the ammunition that is launched is guided there. So that is where the aspect about positioning comes in. Navigation, when we move from one point to another, is the enemy territory, and the timing of coordination between various resources, various combat elements which are using these guidance services, which are using these satellite services. So these are the 3-4 aspects which you have to be kept in mind when we are looking at the TRIAD of the space-based assets as they are getting applied in the warfare today.
Thank you, Brigadier Asthana. Mrs. Neelavathy is a project director which deals with G-Set-7R and G-Set-7B at UR Satellite Center. When you talk about G-Set-7 series, they are seen to be military series. And if military is looking up in the sky or beyond, one is looking at certain attributes of military specs for space support to the military. So I would say that you heard Brigadier Asthana. He is looking at certain areas and you can provide certain support. But I would not say that exactly what 7 does, but what is the expectation of the military from the satellite space. And in that, what is GSAT 7 series do, and how do you think in future you will upgrade your military grade use cases for satisfying the deep strike missions and precision strike? Mr. Deepak.
SIA for inviting me to speak up here. From research organization, I report between the military. I'm with the military organization now, speaking from the research organization. But however, we are supposed to fulfill the needs of the military and their requirements in the space sector, so that there can be, functionally, there is no issues in having the security of the nation. And Sir has told some time back that ISRO has started with all its missions, but not thinking about the military when it started. So I'm too small to comment or give a feedback on that. As such, if I say military in my view, I think it is not only the Army, Navy and Air Force what we have as of today. Even the space industry is also comes as a part of military, which is going to happen in the future. So we are going to be a part of the military when warfare and other things starts, maybe in another 10 to 15 years. So we need to safeguard the space industry also, satellites also, an asset of military in a way or the other. And another thing is, given the topic what is given today, I have gone through the paragraph, like it states that whether we can integrate the services of Earth observation and PNT and then communications together in a single platform. That is how I understood. But it can be understood in too many ways as per the viewer is there. But what I have understood, I will try to convey to this committee what is there in my analysis. Coming to combining these three, if I take, we can start from the space sector down to the user side. So if I start from the space sector, as of today, here we are going to talk only about the satellites which is meant for the military applications or strategic applications. So based on that, if I see, we have Earth observation satellites, which is having a very good accuracy in Carto series. Carto 3 is having some even less than meter accuracy, which is 0.28 meters, I suppose. And we have other satellites like RxSat, ISROSat, OceanSat, so many other series are there. Out of that, Carto 3 is having a good accuracy due to the optical imaging. And that is for military purposes, many of them are there in the Leo class of satellite. Coming to the PNT services, what is provided for the strategic applications, I think it is dealt by the IRNS kind of satellites or Navy kind of satellites through RS part of that spectrum, like whichever is for the civilian usage, that is having a different kind of applications from the same IRNS sector. And for the strategic applications, there is a RS spectrum which is used, RS kind of thing. So these are the services offered. And coming to the PNT services, it is offered from the USAT class of satellite, that is which is sitting at 36,000 kilometers. And coming to the Earth observation class, which is meant for the military observations, including the ELINX services, which is called the TMI-SAT application, where the optical imaging of the surface of the Earth or enemy is not taken. It is only based on the signal what is coming from the, other person's surface. They capture the frequencies, whatever is getting radiated from the ground, through which they know whether some outside agency is sitting there. All the other things are for the optical imaging purposes, and SAR radars are also there, where they can take images in the day and night to suit the advantage of day and night application, whereas the other one has got the advantage of very good resolution. So, what is happening in this topic, what is given, I felt that depth observation is based by the low class of satellite, which is ranging from 600 kilometers to around 1200 kilometers from the Earth. And coming to the PNT and the communication services. Communication services means, like for Navy or Army, you take, we are having communication transponders at the geo satellite to fulfill their voice messages between the users and then from their control segments to the users, and their video signals from between the users and from their own control centers to the users. All these things are there using the communication transponders. So these communication transponders and the PNT transponders are kept in the geostationary platform. Coming to this Earth observations or the electro-optical images or the elite services, which we call it as EMSAT, all these are kept in the lower platform, which is geosat. So these two are having a different platform. And coming to ISRO, if you take, we ourselves, we have different ground stations for different purposes to review. Like we have in Hyderabad and some other places for receiving the data of the images. Whereas we have control centers at NCF and Bengaluru for controlling the spacecraft. And then communication transponders, anyway, the users are taking the signals directly. Like this, the platforms are different in the space for all the applications of military. So I thought whether we can combine all the platform and to have satellites, whether it is the LEO only or GEO only. That way I was thinking. I do not know what is the intention of this topic. I thought like that. So if I think like that, my analysis shows that you can combine PNT with EO in the same satellite. However, you cannot combine communication with the INDO satellites. What is happening is the kind of satellites we make. I am the project director for VSAT-7R, which is meant for the Navy. And we have got around more than 12 transponders in the satellite in the geo class. And coming to the VSAT-7B, it is for Army, which is around 5,500 kg satellite. The kind of transponders we have and the throughput of data we have to give to the Army or the Navy. If I put all those payloads in the geo class of satellites, the platform of the spacecraft will not support such kind of communication payloads because the antenna look angle and spot beams, whatever we are pulling from the spacecraft, it cannot be catered to the users. One reason is the platform stability and the steering and step and steer mechanisms, what is used in the LEO for observing the satellites, observing the Earth platform or any platform, it's a totally different requirement for design of the spacecraft. So the communication transponders cannot be put in the Earth observation platform. That is one thing I would like to say. If you want to have more time. And another thing, suppose even if you devise a mechanism to use it in the lesser orbit for lesser number of users in the LEO spacecraft, then as one of is doing, we should have a lot of network of LEO satellites to do this kind of all the three work like a single platform. But still the satellite design becomes very complicated. Because to have a picture on the ground, we do step and steer mechanisms for taking the picture. At that point of time, the transponders antenna coverage cannot be mixed for the user with a beam accuracy of the beam set. So there are contradicting requirements as per the satellite design is concerned. That is one view. And another view is earlier satellites for Navy were asking what are the improvements we have done in this satellite. If we want to make a satellite, we just take the requirements from the user. What is the requirement? So what best you want your further proceedings or further improvements in your own field, you have to capture it in the terms of how to give it a satellite image. Like, see, I am not part of the Navy, I am not part of the Army, but I am a common public. I can be in your view or in his view. But when it comes to the implementation in a spacecraft, I require a document. What are the requirements for the user which can be implemented on a spacecraft? To some extent, we can translate your user requirements into the satellite platform, but we won't be able to understand very exactly the minutest details of how you want to attack a person or how you want to do with your work. That comes in your work procedures. It has to be translated with technical requirements and you give it to a satellite data. So it is an end-to-end process. ISRO cannot be separate and military cannot be separate. And a receiver person who is designing the receiver today. Now you have a separate receiver for radio, separate receiver for Earth observation, separate receiver for communication failure. Maybe if you want on the ground, you can have a common receiver or some integrated receiver from one agency to have all these applications in the single platform to receive. that can be developed it is an integration of all the signals. But on this spacecraft side, integrating all these three needs, it is a little difficult task if you people want more bandwidth or more number of features or more data. It is a difficult task, but still it cannot be thought about if there is a parity between all the departments of what everybody wants across the same table, keeping all the people. One has to work out and really test. But my experience is we cannot combine Earth observation with other things. That is my view. I may be wrong. It is due to the accuracy what is required.
No, I fully appreciate the point that you're making about, for different tasks, whether for Earth observation, communication, like that, for the different tools for getting the ideal result. I think you are right. There is a little confusion when this topic has been, the way it has been given. It gives an impression that you are trying to integrate all the payloads on a single platform. No, that was not the aim. So let me clarify that what we are looking at is that there is the different platform sensors at different places, but they finally need to have integration between them. One is picking up electro-optical, picture, some Earth observation, but also there is a communication satellite which is doing the talking between the sensors, between the ground stations, surface stations. So the subject for this whole discussion is keep the platform where everybody has to talk. It's like in airborne platform. There is AVAX, there is a fuel, there is various other fighter aircraft, UAVs. They all need to coordinate together to achieve the same aim, go to the same time. So that was the sense, and we totally agree with you that the platform will be where they are supposed to be, where they are supposed to be. Only the quality of sensor.
Common control of state.
Right.
Like there is separate very control and the army control. If there is common control, they are all
Common substation, common timelines. So everybody in the Brig is talking at the same time of the instant position of everything. So the point.
there should be a common agency.
Yes.
So it's not involved there.
Um,
I think it's not there.
I think I'm so mesmerized with this discussion. Therefore, we are not human beings. We're sitting and we are looking at the space and we don't know where it is. Because everybody said this is that same. Earlier days in the cosmic world, we say, "Upar wala sab kuch janta hai, neeli chalni wala sab kuch janta hai." So in your entire description of the number of different types of satellites, different objects, different kind of payloads, and what integrate, what not integrate, I think what Air Marshal Anil Chopra has really said is that for all the humanity, we need our operations to be more synergistic and more hybrid in nature. Whoever does it, whatever, please make sure that we are not struggling to keep 4 different types of technologies and 3-4 different types of enablements. And we are not enabled faster because the speed of the operation is so fast. And I will come to it later. So therefore, let me go on the right track and I will ask more things from the space and data engineering. Is this possible from your engineering perspective of bringing the entire data and all the use cases put together and make a triad to make this job of a warfighter, such as a fighter pilot or a gunner or a missile operator, easy, so that everything is brought on a grid and you don't have to really start saying you are PNT, you are communication, and I don't know if you don't talk to each other, but then what can I do? Engineering.
Thank you, sir. Thank you for this good question. So myself, Pramod, I worked for ISRO for 28 years and right now with XDLINX labs where we have tried to build small satellites for EO communications. And also, so coming to this ISR point which you mentioned, bringing it to a single platform is very much possible. like what I agree to the previous speaker as well. It is not necessarily that you need to have entire solution on one single satellite or one single constellation or one single platform. It is going to be a mix of all the technologies, and we have to synergize all these technologies to bring the complete ISR solution. So this, when I mean ISR for us, it is always what, when, where, and how. So if we have to answer all this, it is not going to be with one single satellite or one single sensor. So we may have to use all these complementary sensors, fuse them, and then generate intelligence. And for this, EVO is one primary sensor would be, but EVO itself will have high resolution imagery, spectral images, spectral characterization, we have to do it. And sometimes the objects are so small and they move from one place to another. That is where we need more elegant kind of payloads where you should be able to pick up the signals rather than the object itself that may not be visible itself. So last session we were also talking about some submarine signals emerging from submarines, low signals. So these can be definitely caught by space. At least we don't have right now the current technologies like this, but in the coming future probably all this will be possible. So what essentially what I feel is that after bringing them to come to one single platform is very well hard, and it is definitely possible.
Shanmuga, you are and you work on the PNT. Giving coordinates is not or tracking is not. We would want to know what we are looking at is located here, and then we do a shoot a sensor combination to it, and the seeker should know exactly how my command post is looking at, the seeker is looking at it the same way, so that the communications are secure, the PNT tells you exactly the ISR application and the type of target which has been identified are on the platform. So how is it that, of course, we are all saying the same thing, that we are not on the platform and we should take it. I think that is the debate, and that is why this session has been designed. So something has been said, it means something needs to be done. Do you have something at the PNT side and of course the background is communication. How do you Earth observation and PNT and communication? Let's shoot a sensor, whether it is Navy, Army Navy or Air Force, we have no problem to shoot a sensor.
Thanks. First of all, I have to introduce 4 members. I'm not a communication person. I have 4 members. That's all. That's all. That's one thing. Then, PNT is a core technology which integrates everything. As a general problem, yes, there is different thing we need to integrate. How do we integrate? Is through the position and the timing. That segment will be given by PNT. And it's an essential component of the military disposition. That's what I explained in the terms. It's an essential component of the military disposition, where, what, when, what, how, and also why a person is there is an important thing. That can be given by PNT, it's very correct. Currently, we have our own satellite constellation. I just want to update on what is the status of this. When they say GNSS, when they say PNT, we should know what is the capabilities and limitations are there. When they say GPS, it is not a global positioning system at all. It is a NavStar constellation of US. Supposed to be looking at NATO batteries, it's a product of Cold War. But it's typical European mindset. They say their problem is world problem, and our problem is our problem. From that point of view, they say it's a global positioning system. Never. GLONASS looks at the polar region. So we put up our own satellite constellation for us in the equatorial region. The combination of all these systems will help us with all Army Navy Air Force in the big game. It has to be that way. Or we have to go for like Chinese is trying to do a thing which is a LEO, MEO and a GEO type of combination and calling it as a nest. We do system they're trying to do. And that's very complicated. I will go after slide 56 and they still cannot do. Next is adoption of this technology is the key to integrate it. It is just not creating a capability. Today we have capability using which we can provide, technologically we will provide you 1 meter accuracy without any DGPS and all other so-called big terms people tell you. Using Mavic, we can give you 1 meter accuracy. What does it translate into is that every soldier can be targeted separately. Every loophole can be targeted separately by missiles. The possibility exists. Yes, we have to integrate this whatever EO, Earth observation people, Earth observation data has to be integrated into PNT, and the communication data should be integrated into PNT. That's right. So now, in case of communication, we are laying it down. Like in case, I just basically what is needs to be updated the existing communication system is that all communication systems have to have a navigation component attached. So it's a kind of axiom. If communication is not location data, our communication is for telling the location. Why have a separate communication for the location? So each communication device should have a locating device inside it. Should transmit its location also when it's communicating. That way we know what the exact location is. Yes, again data, EO data that comes up, or LN data that comes up, or ISR data that comes up should have this navigational component attached to it. It's like cameras. Today cameras come with positional data also. Same thing will adapt into the new. So that everything gets mapped and you can plot it dynamically into a same place without we taking separate means of taking, saying that this is the information got from so and so place, or this is a photo of so and so place. Without telling all that, I should be able to directly see it. So our navigation elements can be put into any type of such equipment. For that, we need to miniaturize the navigation devices. That's what we also achieved. It's there in India where we can have smaller components which can help in retrofitting existing communication equipment and existing warfighting mission per se. For example, if you wanted to, like we are trying to put it on a motor. Motor is one of the most inaccurate item part of the weapon, which is the most inaccurate weapon means it's very difficult to lay a motor like an RPG. Whereas if you can put something on a motor, what I'm trying to do, and increase its efficacy, you have achieved increased efficacy of everything else which is helping the military or infantry personnel. That's what it happens. And this is where you can integrate it. Adoption is a key, because with adoption you get more. One has to understand, in Indian context, we have to understand. GPS when they made, it started in 1980s. Only by 1991-92 we had GPS receivers. It came to Indian Army in 98. I happened to be the first field trials, field trials team. So 98 when we got GPS receiver also in India. 80 to 98, about 15 years of R&D they used it for those years. In India also they adapt, Indian armed forces adapt, whatever it is. It's like something like Mera. And we have to use it, allow people to improve on the existing systems.
It was very frank. You spoke about models, you didn't have to say you were infantry officer. So, it's really getting very interesting because we know something needs to be done and we know it is not there. It means somebody has to do it and we have to find who has to do it. So before Air Marshal Chopra gives his conclusive opinion on what is required, how it should be done, and where he thinks is the solution lying and who should do it, I will quickly go over the audience and say, do you have questions for such a well-informed specialists who are trying to bring the triad together, which is not what is desirable? So anybody can ask a question, and I'm sure we will get answers.
I'm Marshal Chopra. And my question is a very, very basic one, and it flows out of the recent statements that have come out in the public domain regarding lack of demand in the satellite segment because of lack of applications. And we have been talking about it in the last 2 days. Chairman ISRO is on record now having said that. So the question to you, ma'am, is are the services really insisting with regards to the GSAT 7 Bravo that you put everything, the communication part, on the sensors part, everything on one satellite only? Because if it cannot be done, please launch 2, please launch 3. If so, launch capability is there. Your statement is that the satellites are lacking. You launch. If there is an issue related to everything being put on one, have something like if I may use that very lateral thought, something like a wingman concept in satellite domain. You launch 2 adjacent satellites. The data flow between the satellites is something that is already being addressed by the industry, both through the optical and the RF medium, high bandwidth data communication. So let one satellite house all your sensors, other one house all your RF segments related to the communication part for transmission back down to Mother Earth. So what is it that is the problem? There is a dichotomy here that I detect between the statements that we do not have enough applications and satellite, the launch is stagnating, the capability to launch more rockets does exist, but then why are we trying to put everything onto one?
You want to ask? Okay, we can have one or two questions so that then we can.
You have a question?
I am Professor Lakshminarayan from Usman. Just I am wondering, when we have wanted to integrate the PNT with other sensors, the navigation itself nowadays, integration of other sensors, because most of the times we are thinking about space GNSS receivers or something. But even now, still we have to address about the integration of inertial sensors and required accuracy. That's why also a lot of issues are there, basically, because most of the receivers integrated with the inertial sensors are addressing up to 60 seconds of the TXS cost. That means whenever the TXS is ready, still we are not able to address the problem. Most of the times we are always going with GNSS. That is another problem where we are doing, because we are from research and training for navigation connects. And because we are working with GNSS, but we are coming for addressing the problems where GNSS is ready. That is the one. And the other part coming to GNSS side, whenever we are talking about distributed signals, because in the computer science, data side, ethical hacking also people are encouraging and implying some people. Like we have not seen any papers on the jamming and spoofing of restricted signals and how it will be working. Because only defense of space itself is working, that anybody is working. That needs to be addressed like that.
Do you have a question?
Yeah. So,
do you have a question?
Yeah, what is the present status and how we are going to address these issues?
Okay, so we had Amy and Anil question.
So one
or is there anybody else wanting to ask?
I am Major Grover. I have a question for the audience here. We have this NAVIC, our own integrated system coming in. It's got a large number of advantages which have been brought about. However, we are looking at a particular problem where it is not becoming as popular, as convenient, as cost effective as maybe GPS or other systems are. Primarily, I look at it in 2-3 terms. First is the market integration in terms there are not many devices or applications being given to it in the fields of agriculture or in the field of automobiles or other things, which is coming in. The second issue I see is the integration with other GNSS systems, which are world over, like the GPS or the GLONASS, or once it gets integrated and it becomes a bigger issue, then maybe the Navy or the Air Force, who are going in for a longer range or a longer region, can also utilize it. But the third and the most pertinent issue, which I want to know about, is the government policies and the mandates and the incentives, which yes, have been provided to a limit. However, there is a particular feature which is the most important feature for the defense services, which is the security, the anti-jamming, the spoofing, anti-spoofing feature, which calls for the restricted usage of it in the S-band. Now, the government or the authorization resource has to authorize someone so that people can devote their time and attention, funds on the R&D to make this particular issue or make this aspect very good so that this particular NAVIC, whichever, whether it is Elena Geosystems or anyone, gets the authority and can work on it and make it something which is the best in the world. So that is my question.
Thank you. Would you like to respond to some of this?
Whatever questions I am hearing, I am thinking it's little related to the policy matters, but still I will try to answer to the question. He has told that demands are more, whereas the satellites are less, right?
Demand is less. That is what the statement is. One of the problems with the system is that the satellite demand market is floundering, it is low. We have the capability for the rockets, but the satellite
Yes.
statement variant would is back to the journalist.
If I understand that launching facilities are, the application for launching is more, satellites are less. Is it like that? See, if I see that the components what is used in making a spacecraft, many of the components, I can say 80% of them are different from abroad only. Whereas coming to the launch vehicle side, propulsion or any electronic components if you take, it is not to that extent, it can be managed. So if you take for example the DSAT-7 satellite, which is a replacement for DSAT-7 satellite for the new, we are supposed to make it 2 years back. We are not able to make it today because there are some tubes and things which has to come from abroad. And the government policies today, it is not so easy that you can make any component from anywhere. Maybe some 5 to 6 years back, I can say, you place an intent, it was easy to get. Now, there are a lot of policies like Make in India, so many files are blocked. They say that you try to make this component in India and the files are not moving, we are not getting the component. And to make in India such a component, the person who is ready to make, he has the knowledge, he has the money. But today he puts the money and makes the component, only the satellite people will be using it. He is not going to have a global market for his component. So we need to wait for that component to come.
So this is a different problem.
Yeah,
It is a different problem.
It is
So
a
this is
different kind
not
of problem,
an
but it is our problem. It is a nation problem only. But how it will be dealt, I am at too small level to answer. This is the reason, sir. Most of the conference procurement is getting delayed for 2 to 3 years due to this Make in India activity. That is one thing. I think I have answered to you. And another thing,
Can we continue to speak for the TRIAD?
and another thing, what the SR has told in extra for TRIAD, he was saying that security issues and implying that PNT information in the communication link has to come like that. So what is happening in 7 itself, if you see, all your communication links between the usership to the usership, people have their information of the PNT also in it. That we are getting it from there. See, any usership when he wants to get into the network of the Navy, he has to first enter into that through some code and his position and details. After that, he enters inside something. After authorization, only he enters into the network. So that information we are getting by the satellite, and we are getting the same information in the communication.
We need technology to take care of those problems.
It is done. In 7 it is done. And another thing in DSAT-7 is that all the indigenous basebands are developed for 7. In DSAT-7 satellite, look at what is sitting inside. All the basebands are bought out from abroad factories. All the baseband for the Navy ships what is used, it is all bought out in DSAT-7 baseband technology. Whereas in DSAT-7, what we are going to launch, whether it is between userships to userships or between UAVs to the satellite, everything baseband itself, it is ours. It is local only and it is done at a very high security level. Nobody can crack it. Like that, it is given a lot of importance. So that is the thing.
Thank you. Thank you very much. I would request Marshal and Chopra, the chair, to finally give out his viewpoint on the TRIAD requirement and the possibility of it, if it is required, or if there is an alternative, if it is not to be possible so easily, is the human being going to be sitting as a coordinator and pulling things together? And the CUDA cycle is going to be much longer. We will also use accuracy. So we are running out of time. I will request Marshal and Chopra to conclude it and also give us the thank you.
Okay, thank you, General Pannu. Let me first talk about what Marshal Ajay Chopra will say. My personal take on this is, you see, the armed forces spell out their economy, give it to the ministry. The ministry puts the money on the table to give the order to destroy the agency which, and now also the private sector, which will execute what they want. Let's say you have given X requirement or the space agency has given X requirement. They say that I can put all of these requirements in a single satellite, these or whatever, and I will meet, and you will still have spare capacity for more things in times to come. But then you say, no, I want redundancy. So, okay, one satellite, no, we need 2, 3, 4, 10, whatever your satellite requirements. So, we at armed forces, I was speaking earlier with the DGPSA. The armed forces' job is to say what is our requirement. I want such accuracy. I want such latency. I want this kind of redundancy. I must spell this out. Government must assess. They have the money. The launch capability exists. The satellite capability exists. By and large, the sensors, we have technology for sensors. But maybe the accuracies, perhaps can be improved later. So, I think this whole exercise, the capabilities exist. Our requirements are really, if I want a satellite at 1 hour launch or 2 hours standby, the industry has told us in very many sessions that they can keep the satellites steady all the time for you. You're paid for it. And every 2 years, they will even upgrade the technology and you will pay for it. So, so this is how I think the whole exercise needs to work out. And if you want payloads on different satellites for whatever technical reasons that the armed forces, whatever you demand, they will do it. The second aspect, I will cover the Air Force aspect, but let me say 2-3 sentences, though part of it has been covered in the previous session. Yes, the peculiarity of the Air Force is that reach and speed. All the sensors and the satellite capabilities have to reach that range. The reach is global. The C-17 we could go anywhere. Even a fighter, even a missile requires, even a weapon, light weapon, the Balakots like that follow, GPS or some satellite navigation signal. So the Air Force peculiarities are such. Similarly, the targets. Other than airfield, the Air Force's targets are also the targets of the Army, the Navy, because some of them we have to go and strike across the board. So these are the peculiarities. But all of us want latency. We want ISR, which is as recent as possible, warfare in mobile for all the services, high mobility of sensors, shoot and scoot, missile system. We have seen that in the Ukraine war. So this is how it is going to be. And my last point is about the TRIAD. There is no doubt that the amount of information and data that's flowing from the space sensors, each agency, whether it's military or civilian, requires it in different forms, in different timings, in different ways. But we all have to fight the war with it. There could be the Army and the Air Force looking at the same target at the same time. So there is a need for total coordination, like we do airspace management for every asset that's flying, from UAVs to helicopters to fighters, boats and the birds. And including the Army fires, we have to coordinate for airspace management. A similar exercise is required for all the assets that are there in the space, EO, PNT, and the communications. The secure electronic assets have to be secured through electronic warfare. The optical sensors have to be secured from lasers, direct energy weapons, etc. And all these capabilities exist, all these are happening somewhere in the world in some form or the other, and there is a need for this entire triad to be integrated for final applications. The DSA, the IDS, and the three services have to do this exercise, and if there are gaps, that is ask the industry also. Thank you. And thank you, ladies and gentlemen, for the patient hearing. There are still enough number of people in the hall, I can see. And let me thank all the the panelists for their words of wisdom, and let's all put our hands together for it.
Thank you very much for the meeting session. We move ahead with the felicitation ceremony. I request Chair to kind of felicitate the panelists. We'll start with the Shanmuga, then Anurag, Asthana. Miss Neelavathy.